Let's start Chapter 9. In Topic 9.1 in Math 20-1, we have linear inequalities in two variables. For our first example, we want to graph the linear inequality of the form ax plus by is less than or equal to c. Now they're called inequalities now because they're not equal. They can be, but it's also less than, or it could be greater than. In our first example, to graph 2x plus 3y is less than or equal to 6, we're going to rearrange that, and actually we're going to graph 2x plus y is equal to 6. That's going to be our starting point. To solve for y equals blah blah blah, we're going to say, subtracting 2x from both sides, 3y is going to be negative 2x plus 6, and then dividing everything by 3, we're going to get y is equal to negative 2/3 x plus 2. Now you have to recall the equation for a line. Y equals mx plus b. M being the slope, which is the rise over the run of the line, and b is the y-intercept of the line. B is the point where the graph is going to cross the y-axis. Here we have a slope as being rise over run. So the rise will be negative 2, or down 2, and the run will be 3, or 3 to the right. Now, if we take our y-intercept point, which is at 2, or more correctly 0, 2, we can plot that point on our graph, as you can see, 0, 2 as a dot there. Now we can plot other points by plotting in our slope. If we go down 2 and 3 to the right and put another point, now we've got 2 points on our line. Down 2, 3 to the right, we got another one. Down 2, 3 to the right, we got another one. Well, we can do that in both directions, and we can draw a line through. Now we have a line, and everywhere on this line is where 2x plus 3y is equal to 6. But if you'll recall, we want to know where it's less than or equal to 6. Now, every point below this line is going to be less than or equal to 6. So we're going to shade in the whole region below. Every point in that purple region is going to work and be true in our inequality. Every point above it is going to be false. So here we have to determine if the point for B is negative 2, 4. Is it going to be part of our solution or not? Well, notice where negative 2, 4 is. It's outside of our solution area. So if we substitute negative 2 for x and 4 for y, you're going to get 2 times negative 2, which is negative 4 plus 12. And that is going to be 8. Is 8 less than 6? No. So notice that if you plotted that point, it's not part of our solution. Okay, here's your turn. Graph 4x plus 2y is greater than or equal to 10. You can stop the tape, take a moment, do it. Alright, let's correct. 4x plus 2y is greater than or equal to 10. That means 2y is greater than or equal to negative 4x plus 10. Y is greater than or equal to negative 2x plus 5. So notice that our y-intercept is going to be at positive 5, and our slope is going to be negative 2, or negative 2 over 1. So if you start with 1 point, go down 2 over 1, put another point, down 2 over 1, put another point, draw your line through that. Now, we just have to find out, do I shade above the line, being greater than, or below the line, being less than? And since we have y is greater than negative 2x plus 5, we're going to shade be above the line. Is the point 1, 3 part of the solution? Substitute 1 for x and 3 for y. Notice that you're going to get 4 plus 6 is greater than or equal to 10. Is 10 greater than or equal to 10? Well, it's equal to 10. So the solution point 1, 3 is part of our solution. Now in example 2, we're asked to graph 10x minus 5y is just greater than 0. Let's solve for y. We're going to get negative 5y is greater than negative 10x. Dividing both sides by negative 5 will leave me with y on the left side, positive 2x on the right side. But since I've divided by a negative, I have to change the direction of my inequality sign. If you'll recall that when you multiply or divide an inequality by a negative number, you will always change the direction of the sign. Why is that? Well, let's look at an example. If negative 6 is less than negative 3, which it is, that's a true statement, I can now divide both sides of my inequality by negative 3. When I do that, on the left side I'll get positive 2. On the right side, I will get positive 1. Now you'll notice that 2 is greater than 1. And so to make sure that I keep it a true statement, I have to change the direction of my inequality. This is an always. So let's continue. This is the same as y is less than 2x plus 0. I put the 0 there because 0 is going to be our y-intercept. The slope, you'll notice, is 2, which just means 2 over 1. The y-intercept, we said, was at 0. The rise is going to be 2. The run is going to be 1. So from our point that we've plotted at 0, 0, I can go up 2 over 1 and draw my line through. But you will notice now that our line is not going to be a solid line. It's going to be a dashed line. This represents that the points on the line are not part of our solution. Only the points that are now going to be below the line are going to be our solution, not the ones on the line, because we're just looking where y is less than 2x, not less than or equal to 2x. And that's how we're going to represent that on the graph. Here we are. We're going to do a your turn, which the graph 5x minus 20y is less than 0. Go ahead, take a moment to do it, stop, and then continue. Alright, let's continue. We got 5x minus 20y. That means if I subtracted 5x from both sides and divided both sides by negative 20, I'm going to get y on the left side, and I'm going to get 1 over 4x on the right side. But I've divided both sides by negative 20, so we got to change the direction of our sign. Now it's going to say y is greater than 1/4 x. Well, that's what we want to graph. Therefore, our y-intercept is going to be, again, at 0, 0. Our slope is 1 over 4, which means our rise is 1, our run is 4. If we plot those points and draw a line through, and then we make sure that it's a dashed line, we can shade in everything greater than above the line. There we go. Isn't that pretty? In example 3, we're going to ask to write an inequality just by looking at the graph. Well, first thing I notice that by looking at this, we're going to start by saying, what's the y-intercept? Well, the y-intercept looks like it's at 1, 0, so b is going to be equal to 1. Now I want to find the slope. Notice that the next ordered pair that it seems to absolutely for sure fall on is going to be giving me a rise of 2 and a run of 1. So now I have the slope of m is equal to 2. Next, I'm going to notice that our shaded region is just the part above the line, but doesn't include the line. So it's going to be greater than, not greater than or equal to. So from y equals mx plus b, we can say y has got to be greater than 2x plus 1. Another way of writing this, if you rearranged this, would be to say negative 2x plus y is greater than 1. Or if you changed it all to positives, positive 2x minus y is less than negative 1. All three of those ways are the same equations, and you may see those on a test. Here's a your turn. Again, stop the tape, figure it out, and let's keep going. Alright, so we got y is greater than or equal to mx plus b. It's greater than or equal to because of the solid line. Well, let's find out m and find out b. Notice that b, our y-intercept, is at negative 2. Notice our m, if I started at negative 2, I could go down 2 over 1. So my slope would be down 2 over 1, or just negative 2. So as an equation, I'd write that as y is greater than or equal to negative 2x minus 2. That's it. Last example. Suppose that you're constructing a tabletop using aluminum and glass. The most you can spend on material is $50. Laminated safety glass costs $60 per square meter. Aluminum costs $1.75 a foot. You can choose the dimensions of the table and amount of each material used. Find all the possible combinations of materials sufficient to make the tabletop. Well, let's say aluminum is A and glass was G. That would allow me to make an equation such as 1.75 times A plus 60 times G has to be less than or equal 50, because that's as much as I have to spend. But since I want to graph this, A and G don't work very well, so I'm going to change those to X and Y. Now, it doesn't matter which one you pick for X and which one you pick for Y, because you're just graphing the two in relation to each other. Actually, in the book, they've graphed it the other way, with glass being X and aluminum being Y. Now, when you solve for Y, just subtract 1.75x from both sides, divide both sides by 60. You don't have to even worry about reducing this. You can enter this into your calculator right now, just the way it is, with a slope being negative 1.75 divided by 60. And you're going to get a graph of a shaded region that looks like this. Understand that everywhere on that line is going to be equal to $50. Less than that line is going to be less than $50, so any ordered pair in that region is what you could afford, all the way down to 0, 0, and ending up with no table. So in summary, a linear inequality in two variables describes a region of the Cartesian plane. All the points in one solution region satisfy the inequality and make up the solution region. The boundary of the solution region is the graph of the related linear equation, y equals. When an inequality symbol is less than or equal to, or greater than or equal to, the points on the boundary are included in the solution, and it's represented by a solid line. When the inequality is just less than or just greater than, the points on the boundary are not included in the solution region, and the line will be a dashed line. Lastly, you can use a test point to determine which region of the solution for the inequality to shade. Your assignment for this lesson is to do page 472, numbers 1 to 9.